We've got a set here which I've said I wouldn't do another one of, so it's under the strictest rules that we do, and that's a Shogun. I'm just going to swap his fuse, which is 5 amp one for a 3 amp one. Right, that's a bit of a safety thing. Now, it's not come with a mic, so I'll have to make a mic up because it's unique with these. Oh, good grief, here we go. Take a deep breath. It's a 5-pin socket. It's 4 on this. What's that about? Oh, good grief, bang head here. Right. So what they wired it, you know, the normal mic switch, the normal mic socket has power on it for a amplified mic. Now these sets were riddled with dry joints, not because they weren't soldered properly, but because the parts weren't cleaned properly. It's a bit like the Midland 099s, and so within a year of these being new, they were playing up with dry joints, and these have to be one of the least reliable sets of all time, and they were expensive. They don't work particularly exceptionally, and they have a clunky squelch, but they are unusual and they are swish, and they're well made if we take away the fact that none of the parts were properly cleaned. So the importers were Sunrise Products Japan, and the pre-production prototypes came out as Samurai rather than a Shogun. The pre-production prototype had something else high-low instead of power. So I'll switch it on with our 9 volts. Yep, there's no overload, 230 milliamps. We'll now go to 13.8 volts, and it's drawing 330 milliamps. So I'll connect up the receiver. I say we're still going to have to. We've got a mystery mic now, haven't we? Right. So we'll put in 2779125 on the signal generator. I think it's iffy around the squelch department, he said, as in dry joints. What I'll try and do is to do a tune-up and then pass it to Mr. Chippy, who'll go over it for dry joints. And it's quite a faff. You've got to unsolder the points and clean the part and then resolder. It's not just a matter of bunging some more solder on. So we have a fiberglass brush and special tools. I think it was Practical Wireless did a review of those special tools last month. Little kind of pin things. Right. So, what we got? Let's put 100 microvolts on. Yeah, it's lit up, so it's receiving. So I'm going to put a Cybernet standard mic on, just in case. I just hope it doesn't put 12 volts at my mic. Well, it isn't that. I don't know. I'll email the customer because I'm not going through every mic possibility just to damage a mic or the radio. What we will do is open it up, take its photo, I'm supposed to be doing the organ anyway. Now, these are self-tappers, and I don't want to lose those because we don't have self-tappers this kind of size. Come on, open it up. That's it. And it's an unsoldered speaker. So it's been done nicely. They've put all the ferrite beads back on and they've replaced the decoupling capacitors. Yeah, there we are. I'll find out from the customer what it's been wired for. Now the customer's happy with this to go back to 5-pin, but I'm not going to do that until the end because I'd hate this set to be so faulty that it's not worth doing, and then it's good me after bad, isn't it? I'll also need to ask if he needs a mic. So we've got a redrawn circuit diagram which is floating around the net. I do have an original circuit diagram too, which came in the back of the instruction book. They did a layout here, so I've blown that up, and then I've got a photograph as well for us to colour in, because obviously I didn't do enough colouring in my childhood. Now, what it does say is that that is S meter. Well, that's one done, isn't it? And it says that is squelch. Also says that is deviation. That is ALC, which one would expect to be, normally only get that on AM. I would expect that to be transmit, but we won't colour it in yet. And then we've got RF meter, which is hidden under there. We know that's the detector. Good. So what else have we got? So we know that these are the transmit line. Let's check think if that one is. There we go. So we'll start with transmit. Picture in picture on, and hopefully we'll find the right camera. Good. So press transmit. Oh, we'll just unplug this speaker like happens. And the radio's doing 3.5 watts. I've got a bill for some building materials here. Shogun TX 3.5 watts. Frequency. Bit low, but not scarily low. 2779070. Deviation. Wallow. It looks about spot on. And receive. Sensitivity. That camera's moved. Right. Let's see what it's doing. Better plug the speaker back in. Doing 1.3 kilohertz, 1.3 microvolts, 1.3 microvolts for 12 dB. So it should be better than that. So it's been wide unidown. You know, if you're ever in this situation and you get a radio with an oddball microphone like that, make up an adapter lead instead of changing the socket on the radio, because the value of the radio is totally ruined unless it's modified back to standard. Right, we'll go to transmit and see if we can. Oh, I've got to unplug the thing every time. See if we can get anything more out of it. So that was alright, that was at peak. This one feels broken, it is broken. It's very frustrating. I expect this to come from the same source as his other set. I've got to try and extract that. Well, we'll see if we can get the rest of it up to spec, and then I'll have to see whether Mr. Chippy wants to unsolder. See if we can get it out. That's brought it up to 3.6. It's probably about where it's going to be, so we will need to get that out or find a way of removing that, but for now we'll leave that as it is. So deviation, try it there. Wallow, 1, 2, wallow. No, that's now too low. Wallow, that's spot on. Let's see if we can do the frequency. Now that's going to be in this box, isn't it? Got to try and feel for the trimmer. There it is. One of those, it's a bit vicious. I think we'll leave it there slightly high. Right, so we won't deal with the power meter because the radio still needs that core changing. Low power isn't adjustable, but out of interest, the radio is doing what? 350 milliwatts. So I think we're there. I think we've covered that, everything on. Yep. So plug the speaker back in. And the first thing I think we need to do is set the detector. Turn the bench light off so we can see what we're doing. Put an S9 signal on the radio, turn the volume up adequately to be able to play with that. And the detector is there. Wow. That needed a bit. So now we'll go over to the SINAD meter, see whether we can just get a bit out of it. So that was already at peak. Just drop the attenuator a bit. What am I doing? Yep, that's alright. A bit more signal on. I think that's it. Let's see what we're getting now. Getting 0.65 microvolts. So that's that done. So the S meter is absolutely spot on the 9. Let's go up from there. Can we ever get plus 30? We can. Yep, that's set right. If it wasn't, then the S meter is the back one of the two presets, which is variable resistor 5, can't speak. Squelch, just put squelch to full. And we'll see whether we can open it up, preferably at S9. So 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts. So that is too strong. We need to drop that down. So what will open it? A bit more. So that's its weakest position. So it's about 150 microvolts to open. So at least it does open. So now we'll go to putting the squelch to threshold. Switch the signal generator off. So park that at 0.3 microvolts on standby, set the squelch to threshold, switch the radio signal generator back on, straight in. So it's coming in at 1 microvolt and it's leaving 0.75 microvolts. Another bit of a clunky squelch, but that works absolutely fine. So I've adjusted that as sensitive as I can. So we need to do something about this broken coil, and we need to do something about his dodgy squelch. So we'll unplug it. So I'll pass this across to Mr. Chippy to see what he can make of any dry joints in the vicinity of the squelch area. We'll also clean the board. Right, pause the video. Right, this has come back from Mr. Chippy's domain. He's gone round all the squelch. I'll go over with isopropyl alcohol. He's done all this. He's taken the solder off. He's put it back on, and so he's done all this area, and that area. He's had the front panel off, and he's changed the squelch control because it had been changed before, and it hadn't been used. It hadn't been done properly, shall we say. He was unhappy about that. So he's done this coil, and hopefully. Let's see what result we get. Switch the picture-in-picture back to that meter. So I think we were at 3.6 watts before. May not make no difference, but at least it's not broken anymore. He's taking it out. It's one you can get to the other side and just turn the core round. So here goes, transmit. Oh, yeah. Still 3.6 watts, but at least it's done. So it was broken at the peak position, but we can't risk that. I'll just make sure these others are peaked. And that hexagon one. There we go. So that's that done. And then we're going to reset. I'll just re-evaluate the squelch. So with the squelch on full, let's get the signal generator on. Put the speaker back in. The other thing that I've noticed, these aren't supposed to have a plug-in socket, and this has been nicely done. It looks like it's been recovered out of a uniden type of set, and it has been nicely done, but it's supposed to be a permanent power lead. So it's interesting that they've made that uniden standard and they've done the mic uniden standard. Right, receive. Let's make sure we're spot on frequency. Still we are. Make sure the transmit is. Gonna get a nasty feedback. Let's put it to low power. It's fine. And here goes. So I'm going to turn the squelch to full, and before it was coming in, the most sensitive we could have it with the squelch on full was about 150 microvolts. So let's see if it's the same. it is the same. So it doesn't change the parameters, but it does work reliably. And we'll do the bottom end again. So park the signal generator, set threshold, switch the signal generator back on, straight in at 0.3 of a microvolt. Now this is improved. So squelch is coming in at 2.8 microvolts. Sorry, start again. Squelch is coming at 0.28 microvolts. And it's closing again at an incredible 0.06 microvolts. This radio is still hearing right down there, regardless of what the SINAD is, it's still hearing. So once again, I'll put this on the attenuator and you can see that I'm not telling you a load of codswallop. So we're on the 0.3 scale. So there we are at 0.3, and as you can hear, it's opened. 0.15, and there we are, it's closed again at if we're on the 0.3 scale, it's closed again at 0.13. 0.13. So let's turn the squelch off on the set, and let's just hear how far we can hear down to. So there's 0.2, 0.15, 0.13, which is where the squelch was coming in. Let's turn the tone off. Yeah, you can just hear it down to 0.1. So I'm going to just take another SINAD reading, just in case it's altered with the dry joints, because that's incredible where it's hearing down to. There's our 12. Let's see where we are on here now. So it's, where were we before? Yeah, it's 0.65. So it hasn't changed, but the set certainly can hear further with, of course, increased noise. Just for the record, what's 20? 20 dB, we're looking at 2.2 microvolts, and for 10 dB SINAD, we're looking at around 0.55 microvolts. Now we can put the tone on and change all this. Does it have tone on this set? Oh no, it doesn't. So I can't put the tone on and change it. It was that base station which had the tone. So there we go. That should be now as reliable as these are going to be. But it's a lot of work to make them reliable. And I did say we won't be taking any more in for repair, and then we went and did this. Right, that concludes it. I'll put the lids back on. And just a conclusion, we've actually gained some more SINAD readings since putting it back together. It has improved. So we've now got 0.56 microvolts. The screening of the radio, that's why we check them with the lids off first. So it's now 0.56 microvolts. We'll just finally check the transmit. It's 3.8 watts with the lid on. So there we go. So we're going to do a scratchy corner test on this after I've just put it on the aerial, and then I'm going to leave it on all night and make sure the set still works tomorrow morning. Then if we've time tomorrow, we'll start the third set in this chap's box, which is a LCL communicator and I440DX. So, it's on the aerial. Let's turn picture in picture off. One Roger. Empty noise there. This is what I love about living here in the middle of nowhere. Absolute silence. There we go. Thank you for watching. The Shogun. Bit of a sort out there. And it's all worked out in the end. But, you know, we would... Really, it shouldn't have that 3-pin socket on the back, and really it should be having the 5-pin mic connector put back, but I don't think we need to do that on this occasion with this customer.